Hello and welcome to the conformal cooling webinar here on the DME booth on the Fakuma. Conformal cooling is really important for three-dimensional plastic parts like this gecko here, and to show you what means conformal cooling in this case, we should have a closer look on the heart of the mold inserts. Here we can see the mold inserts, and now let's have a closer look into the center of the inserts, what we brought in to make sure that we have the best possible cooling in the mold. If we have a standard cooled mold insert, we can compare that with a classical car. So it will run, but it is not really fast. To speed up the process, or to speed up this mold, we have to use some tuning methods. In this case, we are using a special cooling layout, as you can see here, with three-dimensional cooling lines as well as copper to remove hot spots. This copper has a heat conductivity of 384 watt per meter in Kelvin and is firmly bonded into the steel skeleton. There are more benefits for conformal cooling than only faster cycling. For sure, cycle time reduction is one of the most important things, but we have also influence on process stability, wall page optimization, scrap rate reduction, we have a faster process setup, and we have a better control over the shrinkage of the plastic part. Let's look on a practical example. Here we can see a part out of the automotive industry. It is part of an automotive seat, and you can see that this part has a U shape. This U shape has to be molded within slider. This slider is really hard to control if we are talking about the temperature due to the small shape of the slider. We can see here that we have a drilling layout which is really far away from the main surface, which is covered by plastic material. So that means generally this slider is critical for the cycle time. What we did is we increase the heat exchange surface by using our technique to bring in a conformal cooling, which means also that we have a much more homogeneous surface temperature as well as a quicker heat transfer. So that means that we are able to have a big influence on the cooling time. If we see a classical injection molding cycle, 66% of the cycle is normally cooling time. In this case, we are calling it total cooling time and includes also the packing time. By using conformal cooling, we are able to save about 50% of the cooling time, which means that we are able to shorten the cycle by 30%. Looking now on the economical figures, let's talk about the economical aspect of conformal cooling. We can use the return of investment calculation to show the benefit of this technology. In this case, what we saw before, the U-shaped part, we had an invest of 11,200 euro and we were able to save around 22,700 euro in the first year. That means that we had a return of invest of less than 6 months. And over lifetime, we were able to save around 160,000 euro by using conformal cooling in this mold. As we all know, time is money, so let's work on the performance of our molds by using conformal cooling to make sure that we can increase the productivity of our injection molding machines to earn more money in the same time with the same machines. If you would like to see the use of conformal cooling in your processes or your molds, or if you would like to see how much this technology can bring you, just contact with one of our sales guys here on the booth and ask what we can do for you to increase your productivity by using conformal cooling. Thank you.